Okay, today we're going to begin chapter 3. And in general, this is called linear programming. The title of the chapter says Linear Programming, a Geometric Approach. Section 3.1, we're going to start out talking about just basic linear inequalities and doing some things with those. Inequalities as opposed to equations. Everything we've done has been equations. Now we're going to do inequalities. So in this chapter, we learn how to solve systems of inequalities. We start out by reviewing what inequalities are and how to work the algebra with them. The next step is to review the graphing concepts of inequalities. Once we've done all that, we will learn a geometric approach to solving these systems. Geometric in this case means graphing. This method is called linear programming. Many of you will like this section, or at least like this chapter, because this might appeal to your artistic neighbor, your artistic talents, because many of you like to draw and things like that, and graphing's a little bit like that. So my suggestion before we get going any farther is do everything on graph paper. So have graph paper available. What I would do is just get some and put it in your book and use it as a bookmark if nothing else. And then a straight edge. So I've got one right here. That's an old straight edge I had. That's a little 6-inch ruler. And you're not going to use it to measure anything, but what you'll do, you'll use it to draw a straight line. And again, you can put that in your book and just keep that as a bookmark if you want to. I can't emphasize this enough in this method. It is important to have straight lines and be neat with your graphs, because many times you're going to look at your graph and basically come up with the answer from there. At least that's what you're supposed to be doing. We'll find out later on there's a different way of coming up with more exact answers. Okay, so inequalities are basically these symbols here. These are your signs. Less than, greater than. If I put a line underneath, that's less than or equal to, and of course greater than or equal to. Okay? Sometimes they call these signs of order. So instead of calling them inequalities, order, because less than, greater than gives you an order of size, if nothing else. Okay? Then back in algebra, you talked about some properties of inequality. What can you do, what you can't do. So let's talk about the addition property of inequality, and it's the same for subtraction, so I just put that in parentheses. So let's say we have this situation. In algebra, we have some a that's less than b. So it's two numbers, a is less than b. And c is any number you want. Then you could take a plus c less than b, or you could say a minus c is less than b. So you could add the same thing to both sides, or you subtract the same thing from both sides. So, got a couple examples. So if 2 is less than 4, then what that means is if I got 2 on the one side and I got 4 on the other, I could say, I'm just picking a number, let's say 1. And that was less than, so this is less than 4 minus 1. So 2 minus 1 is 1, 4 minus 1 is 3, 1 is less than 3. So you start out with 2 less than 4, you subtract 1 from both sides, it's still less than. Okay, an algebra problem here, you get 2x plus 4 is greater than 20. So if I subtracted 4 from both sides, I'll write it in this manner. So 4's drop out, so that leaves you with 2x. It's still greater than, and 20 minus 4 is 16. Then later on we'll end up dividing both sides by 2. So you get x is greater than 8. Here it makes a little more sense because you don't really know what the value of x is. So when you subtract 4, does that change anything? Well, according to this property, no, it's going to stay the same thing. So that keeps it x greater than 4. And basically what we did, we simplified everything down where you had just x on the one side. Okay. So again, we're kind of reviewing some things on inequalities. Let's talk about multiplication. Multiplication is a little different. It's a little trickier. If A is less than B and C is positive, so if you multiply both sides by C, A times C and B times C, the sign stays the same. It's less than. And by the way, if this was a greater than, then that would be a greater than. Where the monkey wrench comes in is when it's negative. So here you got A less than B and C is negative. So if I take A times C and I take B times C, notice what happened here. That sign switches. It went from less than to greater than. So just make a mental note. Anytime you multiply or divide by a negative number, the sign switches. Okay, so let's take a look on this one. This says 2 is less than 4, so A is less than B, and C is what? It's positive. So that means if I take 2 times 2, and I take, on the other side I had a 4 times 2, so that's 4, and that's 8. See how that's still less than? So when you multiply by a positive or divide by a positive, it stays the same. So if you go back up here, if you have a positive and you're multiplying or dividing, the sign stays the same. Okay, let's look at this one. Here I've got a 2, and let's say I multiply it by C, which is negative 2. And then I got a 4, and I multiply it by negative 2. 2 times negative 2 is negative 4. 4 times negative 2 is negative 8. Which of these two are bigger? Well, negative 4 is bigger than negative 8. See what happened to your sign right here? That was less than. This is what? Greater than. So anytime you multiply or divide by a negative, you got to switch the sign. Okay, so here we've got a simple problem. If I wanted to solve that for x, I got 2x greater than 10. So you would divide both sides by 2. Put the answer over here. 2x divided by 2 is x. 10 divided by 2 is 5. And since this is positive, that means the sign stayed the same. So x is greater than 5. Didn't write that correctly. So now let's say I've got negative 2x greater than 10. I'm going to divide that side by negative 2. I'm going to divide that side by negative 2. So the negative 2's drop out. I got x. 10 divided by negative 2 is negative 5. Okay. So since that was greater than, I divided by a negative. I'm going to switch the sign, so instead of greater than, that becomes less than. Okay, move on. So let's do some harder inequalities and see what happens. And you're going to find, you're going to do the same thing that you did when you had equations. Follow the same rules. You can add the same thing both sides, subtract the same thing. But multiply or division, if it's negative, you got to flip the sign. Okay, so on this one, basically you're simply going to subtract 4 from both sides to solve for x. So the 4's drop out, you got x. Since you're subtracting, the sign's going to stay the same, so x is going to be greater than 3. Okay, that was easy. Let's look at this example. Here we got negative 3x plus 2 is greater than or equal to negative 1. So we're going to subtract 2 from both sides. That gives you negative 3x greater than or equal to negative 1 minus 2, that's negative 3. Now what? We got to get rid of the negative 3, so we're going to divide by negative 3. So the negative 3's drop out, leaves me with x. Now I divide by negative, so the sign is going to switch. So that's greater than or equal to. I switch it around to less than or equal to. And negative 3 divided by negative 3 is 1. So you're still following the same rules. Okay, they throw in a couple other things. I'm going to touch on them. So let's say we have this inequality, 2x minus 3y greater than or equal to 9. We may want to graph that. We may want to put it in slope-intercept form. So to do that, we get the x's on the other side, and to achieve that, we're going to subtract 2x on both sides. So the x's drop out. That's going to leave negative 3y. I subtracted, so the sign stays the same. It's still greater than or equal to. And here it's going to be 9 minus 2x, or I'm going to rewrite that as negative 2x plus 9. Okay, then the last step, we got to get rid of the negative 3, so we're going to divide both sides. Actually, just divide everything by negative 3. So that leaves me with y over here. When I'm dividing by negative, that's going to flip that. It was greater than or equal to. Now it becomes less than or equal to. The two negatives drop out. I end up with 2/3 x. And 9 divided by negative 3 is negative 3. So I got minus 3. So part of the lesson here shortly will be to graph this. And if you did that, now you know your slope's 2/3 and your intercept's negative 3. And we can do that. Okay, then every once in a while we get a problem. I've never seen them really take a section or an example just for this, but the vertical form of a linear inequality. What that means is you're solving for x. Since there's no y's in this inequality, we're just going to get x by itself. Okay, so to do that, we're just going to multiply by 2 on both sides. The 2 gets rid of the half, that's x. It's positive, so that's greater than or equal to, and 2 times 4 is 8. And that'll make that a little bit easier to graph. If we would have had a negative 1/2 here, let me just do it down here. I got a little bit of room. So if I would have had negative 1/2 x greater than or equal to 4, so everything